In Update 1, an attempt was made to produce the tower section for the Terex tower crane, and that also included a temporary support base. But some parts of it were not quite so good, and that included the floor of the landing, which was made of black plastic plates, whereas the real crane has a mesh floor. Also, I wasn't happy with the geometry of the tower. Along one edge it was 7.5 inches from corner to corner, but along the other edge it turned out to be larger, and that was all caused by the spacing of the parts used. So, as is often the case with Meccano, a rebuild was necessary and a different tower section has been formed. Among the changes, the first tower used cheesehead bolts, and for the new section, and therefore for the rest of the model, we switched to the new type hex head bolts, and these are much nicer to use. The landing floor has been changed to some of the later issued Meccano parts, and it's made of narrow strips with 1/4 inch holes. That makes the platform floor look much more like a mesh floor, and for the moment we'll stick with this method for producing mesh floors. There's also been an improvement made to the access ladder, and it now has a safety cage formed of some later released curved Meccano parts. Although these are not as thin as you see on the real crane, they are a reasonable compromise using standard Meccano parts. Another improvement is that the tower is now made on a completely square geometry, and the main purpose of doing that is to make adjoining sections of the crane easier to fit together. The real crane can be fitted with a climbing frame that it uses to make itself taller, and to do that it jacks off special lugs which are welded on one side of the tower. So we've added a representation of those onto this model tower also. I don't know if I'll ever add a climbing frame to this model. I need to get the crane finished first. The method of connecting sections together stays the same. It uses threaded rods. So far the model is designed to have 2 at each corner, but in fact the real crane uses 4 bolts at each corner. This tower section is quite big and heavy, so let's check it out. And it weighs nearly 6 pounds, or 2.6 kilograms. The crane being modelled is often fitted to the top of concrete cores, and to do that a special piece of steelwork is used. Here is a picture of a couple of steelwork fabrications stacked one on top of another before they're fitted to the top of cores. And for this model we've made a representation of one. It's not strictly part of the standard crane, so we've made it of a different colour Meccano. It consists of a couple of big beams joined together, and there's an access platform in the middle. And the tower section can be lifted and dropped in onto the top of it, and securely bolted down. Of course, the blue piece of steelwork will have been securely fitted to the concrete core of the building. With this design, the operator can come down the ladder of the tower, onto the platform, round, and then down onto another ladder and into the building. Let's check out the weight of the steelwork fabrication, and it's nearly 6 pounds, and that's about 2.7 kilograms. The next piece of the model is what Terex calls the slewing unit, and it's used to rotate the crane. This is a particularly heavy and complex part, and it's actually difficult to model in Meccano. For the model it's been made in 2 sections, and this is the lower part which fits to the top of the tower, and it will be connected using screwed rods as we've seen before. Taking a look inside this bottom section, we can see that there's a circular girder at the bottom, and at the top there's a circular toothed ring. Building this takes a lot of care because the 2 circles have to be absolutely aligned, otherwise the turntable won't work properly. Again, because of the geometry, there's lots of places where the holes don't line up, so you have to be a bit clever to make sure there are strong connections. All of the weight of the crane gets carried on that circular girder, so you have to be careful to transfer all of the load into the outer structure. To form the turntable we use a roller bearing, and this is a specially made up part using small brass pulleys. It fits inside this lower section, so we need to carefully insert it and rest it on the upstanding edge of the circular girder. The circular girder is then a running track for the roller bearing to rotate on. And then the idea is we put another circular part on top of the roller bearing, and the crane is fitted to this part. And by doing this, you can now see that the crane has something to rotate on. The toothed ring will be used to provide some front and back bearing, and also drive pinions will be used to rotate the crane. So here is the top section of the slewing unit, and it's securely fixed to the circular girder. Also at the front and the back there are a couple of toothed pinions, and these are used against the tooth ring to provide some forward and backward bearing. The whole thing fits inside the lower part of the slewing unit, and we have to make sure that that blue circular girder fits properly on top of the roller bearing. Once it's all properly located, it then rotates smoothly enough. And we've also installed a drive pinion on one side to be able to temporarily rotate the crane. Later we'll add a second one on the opposite side, just like the real crane. And at the moment the side plates have still got to be added on because it's difficult to get access inside. Up on top we've added some connection points. Just like the real crane, the slewing unit is a heavy part, and it weighs over 8 pounds, or nearly 4 kilograms. The slewing unit has been awkward to build because of the scaled dimensions of some of the parts. For instance, this side dimension is a non-standard 8 inches. Hopefully this whole slewing unit works well, but when the crane is fully built it will be very heavy, and we'll see if this construction is up to the loads that it will have to carry. The next part of the crane is called the upper slewing ring support A-frame, and this is another heavy and robust part. Here you can see how it fits onto the top of the slewing unit. So using a giant hand crane we can lower our part into the top of the slewing unit. This is another quite heavy piece, and it weighs in at over 2 pounds, or about 1.3 kilograms. It is another difficult part to model in Meccano because of the way it's fabricated, and in particular there's that large top tube. So here it is modelled in Meccano, and it's got the classic A-frame shape, and it's made up of a number of compound pieces. There are brackets to fit walkway platforms later, and we've also modelled the lifting eyes on the real frame. Here you can see that the tubular fabrication is made up of a number of straight strips, and it's all fairly complicated Meccano modelling. Just like on the real crane, the A-frame fits to the slewing unit using pins, and hopefully these pins will be strong enough to take the loads when the model crane is finished. At the top of the A-frame, and again just like the real crane, there are pins to add the next parts of the crane. So that's how far we've got in this update. Progress has been slow with many rebuilds, but at least so far it looks reasonably good.